Hello students and welcome to another lesson in our C# Fundamentals course. Last week we discussed how we can structure solutions into projects into namespaces, and how we can add classes to namespaces. However, we focused on the very basics of classes, so-called static classes. I told you that static classes are a great way of combining methods which have a common theme, which belong logically to each other. They can be grouped into static classes. I gave you a homework, and your job was to create some static classes with which we can calculate the area of geometric figures and also scale these figures. So imagine that you have, I don't know, a mobile phone, something like this, and you want to scale the area of the phone, and our job was to calculate the new width and the new height that we need in order to multiply the area by a certain factor. I hope you tried the homework. You have a sample solution in your GitHub repository, and I would like to walk you through this sample solution and then make the next step together with you, so that for the first time in this course, for the first time in the second year of your career here in this school, we are going to work with not just static classes but real classes. So together we will take the first steps towards object-oriented programming. Now let's take a look at one example, a simple example. That's the static class circle math, as you can see it here. Let me zoom in a little bit. We are talking about this class here. The core element of this homework was to implement two functions on three different geometric figures. The first function is called calculate area. And the job of this function is to calculate the area, in this case, of the circle. And this is pretty obvious. Of course, you know the math. It's radius times pi, that's the area. And if we would like to scale the circle, we simply have to calculate the new radius by taking the old radius and multiply it with the square root of the factor. And this formula is essentially the same for circle, for rectangle, for triangle. It's always the same. Take the square root of the factor, multiply it with the old value, and you will get the new value. So please take a look at this class here. Oh, I just recognized that I made a mistake here. This should of course be a static class. I'm sorry about this. This should be a static class. This is what we did last week, okay? So we see that this static class is just, let's say, a container for functions which belong logically to each other, but they are not really connected to each other. And the static class is then part of the namespace. And remember what we said last time, the namespace is then part of a project. Here you see the project. And the project is then part of a larger thing which is called a solution. This is what we did last time. Let's take a look at the rectangle class. Oh, I screwed up big time here. Of course, this must be static, and I guess I made it wrong here too. This has to be static. I'm sorry about that. I'm pretty sure that I told you that last week in the lesson, but I didn't add it here in the sample solution. I will definitely fix that in your GitHub repository. I'm sorry about that. So now we have three static classes. All of these classes follow the same pattern. Let's take a look at rectangle. We have a calculate area method. In this case, it doesn't take a radius because the rectangle is defined by its width and height, and we simply do the math. And then we again have the method calculate scaled dimensions, which take the old width and the old height, the factor, and calculates the new width and the new height. By the way, this was a small little addition that we did last time. Please remember that. This is a tuple. A tuple is a combined data type where you can take multiple data type and combine them into a single logical value. This is what a tuple is, and by using the tuple here, we can return multiple value. Well, we don't return multiple values here, we return a single value, but this value is a tuple and therefore consists of multiple values. So this is what we did last time. Let's finish by taking a look at the triangle. Here it is again a static class with the calculate area and exactly the same way calculate scale dimension. So these three static classes work essentially identically. Now, what I also told you is that you have to build a user interface for this geometry calculator, and I did that for you. If we take a look at the code, it's pretty obvious. First, we ask the user if she wants a rectangle, a circle, or a triangle to calculate. Then we ask the user for certain parameters. In case of the rectangle, we ask for width and height. In case of the circle, we ask for radius. And in case of the triangle, we ask for the base length and the height, as you can see it here. Then we ask for the factor. What should be the scaling factor that we want to do? And then comes the interesting part, because then we are using the functions from our static classes. Here you see the first one. Here you see the second one. Here you see the third one. And by using these functions of the static classes, we used the business logic from the class library. Here you see another function from the class library. Here you see another function from the class library, and here you see another function from the class library. Red is rectangle, yellow is a triangle, and green is the circle. Now this was just repetition. So now we would like to change this code and make it even more interesting and more beautiful. Let me show you how we do that. Let's take a look at the circle math here. The circle math is, not really beautiful, because if we take a look, then we see that the circle math receives the radius of the circle for which we want to calculate the area, or the radius for the circle that we would like to scale. Both functions, all the functions, they are somewhat related to a circle with a given radius, but we have to pass in the radius over and over again. And if we change the radius, let's go back to the program here. If we change the radius, which you see here, we again have to remember the new radius, and if we want to calculate the new area, we have to pass in this new radius again to our method. So the problem here, the fundamental problem, is that we have methods, in this case calculate area and calculate scale dimension, and they are coupled, they are linked to certain data, in our case the radius here. So we have multiple methods which operate on the same data. They are coupled to each other. And this is exactly what circles are all about. With circles, with classes, we cannot just group methods which have a logical connection, but we can combine data plus logic. This is exactly what classes are all about, and this is what we are going to do here with the circle. So first, we remove the static keyword, because now we are talking about regular classes, not static classes, but regular classes. Regular classes can combine data and functions. Okay? Now, we want to extract the data here. We want the radius to become part of the class and no longer be a parameter for the method. And we are going to do that by using a brand new concept that you haven't learned so far. Let me disable GitHub Copilot here. And we are going to use a so-called constructor. A constructor is a method which we can provide, which we can use to create an instance of the class. Now, what is an instance of the class? An instance of the class is a new circle. There doesn't need to be a single circle. We can have multiple circles, and therefore we need multiple instances of the circle class. By the way, we can rename this method because now it really becomes a circle. So the constructor, let me write that down for you. Constructor is used to initialize, to create a new circle. And in C#, you create a constructor as follows. You say public, then the name of the class, you repeat the name of the class, circle, and then a constructor is somewhat like a method. You can use parameters for the constructor. You can take the radius and give it as a parameter to the class's constructor. And we do no longer need the radius later down here, and that's the beauty here. We can store the radius in the circle, because now the circle is a thing. It is an instance. It is a thing in memory that has on the one hand side data, our radius, and on the other hand side methods, and they belong to each other. They are good friends. Okay? Now, how do we implement this constructor? Just like a regular method. But somehow we need to store this value. We need to store the radius, because currently the radius comes into the constructor, but then it gets lost. And for that, we store this radius, in this case it's the radius, yes, in a so-called property. Let me show you how we do that. We create a property, public, to make it accessible from outside, data type double. You see it. Then we give it a name, a radius. Please note that the arguments of the methods have lowercase letters, and the properties, let me write that down here for you so you can remember this term, properties, this is a property. The property names start with an uppercase R, okay? And then we have to specify whether this storage inside the circle is readable and or writable. And in our case, let's keep it simple. They are readable and they are writable. We can get the radius and we can set the radius. Now we have, let's say, a storage element. Somewhere we can store the radius inside the circle. And this is exactly what we are going to do here. We simply say radius with the uppercase R equals to radius with the lowercase r. So we are transferring the parameter that we get in the constructor into the storage property where it is stored inside the circle. I hope you could follow along so far, but we have a bunch of additional exercises so you really get familiar with these terms and with this way of programming. Now let's think about this calculate area method here. What we can do is we can first remove the static and make the method be part of the circle class itself. But because it is part of the circle class already now, because it's no longer static, a simple collection of unconnected classes, it's now non-static. It's a so-called member function. We do not need the parameter radius anymore, because as this method is part of the class, we can simply here access the data, which is also part of the class. So all we need to do is we need to change that one to the property, because this is where we store the radius inside of the circle, and we are good. We now have calculate area. Awesome, no parameters, much cleaner, much more beautiful. Now here, with the calculate scale dimension, it becomes even more beautiful. First, we can remove the static. We already know that. Then we can remove the radius parameter because we already have a radius. But do we really need to return the radius anymore? No, we don't, because the radius is stored inside of our own class. So therefore, we do no longer return double, but we return nothing, and we change our code so that we change our own radius. We can do that. We are a member of the circle class. We have the radius stored inside our class, and therefore we can simply change it. And next time the user calls calculate area after doing some scaling here, the user will get back the new radius. Isn't that awesome? Now we really have built a class which combines, let me do that in red here, the data, this is the red part, and the methods or the logic here in green, which operates on this data. And that's the whole idea of classes which are not static. I will repeat it again. They combine data, store this data inside the class, with methods that can operate on this data. Now we have two steps more that we can go, because if we want to make it really beautiful, we have to change calculate area and change this one a little bit. First, let me talk about this method here. I don't like the name of this method, calculate scale dimension. This method name was great when we returned the new radius, but now we do not return the radius. We migrate, we change our own data, and therefore I would prefer a method name in this case, which I will call scale. It's a verb. I tell the circle to scale. Hey, circle, scale yourself by this factor, meaning change your own area by this factor. And that is beautiful now, because that scale verb does really reflect the intention of this method. I have a circle in my hand and I tell this circle, scale. And then it will scale and it will change its own data. See? Now the name reflects what this method really does. And the second thing that we can make a little bit more beautiful is this one, the calculate area. Now you have to understand that these properties here, like the radius, they do not need to store data. Properties, if they are read-only, they can also reflect a simple calculation. So if I have something like this here, where the result of the method is a really simple calculation, just a little bit of multiplication and addition and things like that, we can make this thing another property. And how do we do that? By simply saying here, this should be area, but the important thing, remove the brackets here. We do not want the brackets here. We simply say this is a property and the formula that we would like to calculate is written like that. So let me zoom in a little bit and talk a little bit about what we do here. This is a read and write property. We can get data out of it and store data in it. Now the second one down here is a read-only property. We cannot store the area. The only thing that we can do is we can get the area by doing a rather simple calculation. And this is exactly what we are expressing here. The red thing is a read and write property. The yellow thing is really a read-only property which does a simple calculation. And therefore, it's a good candidate for being a property. So now we have a class which consists of a constructor with the initial radius. We have some data that we can store and maintain, radius. We have a calculated property which does a simple calculation, and we have the scale method. Awesome. I like that. Let's practice that again. On the left-hand side, I have the circle. And now we are going to try to apply the same concepts to the rectangle. Okay? So what do we have to change? First, we have known that we do not need static anymore. Static was for babies. No, static is useful. Static is really useful. But still, static was the simplest first step. Now we have real classes that combine data and methods. We changed the name to just rectangle because now it's not a collection of math-related functions about rectangles. Now it is the rectangle. Next, take a look on the left-hand side. We created the constructor. Can you remember what the rules are for the constructor? First, we define that it should be public. And then the constructor is very similar to a method with the very important differentiation that the name of the method must be equal to the name of the class. So rectangle. Now, what are the arguments that define the rectangle? What are the initial arguments? Well, they are the same as here. So we can simply cut out these parameters and move them here to the rectangle. This is exactly what we did on the left-hand side too. We took the parameters from the calculate area methods and moved it here into the constructor, because we want to store these defining data elements of the rectangle inside of the class. Okay, this is good. Now let's again check the circle here on the left-hand side and verify what we did next. The next step was this one here. It was the property in which we would like to store the current state of the rectangle. So this time we have two elements here, not just one radius, but we have width and height. So let's store that. Public double width and make that readable and writable. And the second one is pretty obvious, right? We simply duplicate this line and rename it to height. Now we have two properties where we can easily store our width and our height, just as we did here on the left-hand side. So let's do that. Let's store width with the uppercase W and width, sorry, I mistyped here, width with the lowercase w. Same is true for height. Height with the uppercase H and height with the lowercase h. See? So what we did now is we took here the values from the constructor parameters and store them in our properties, which hold the data of the rectangle. Okay? I hope you could follow so far. Next, we are going to apply the same changes that we did on the left-hand side. We remove the static. The area returns double, that is correct. We change it from a method to a property, area. We define the calculation, something like this, but we have to make it so that we access our properties and they now have the uppercase letters. Remember, I will repeat it again. Method arguments have lowercase letters and properties start with uppercase letters. This is important. Remember that. Follow that rule. Okay, very nice. Let's do the last one. Here, let's check what we did here. We changed that to void. We changed that to scale. We do no longer need to specify the width and the height because the width and the height are already stored in our properties. And the last thing that we have to do, we simply have to, uppercase W, change our own width with the square root of the factor here, and here to the same to the height. Clean up a little bit, and now we are good. I will repeat the concept again so you're pretty sure to understand it. We have a class. This class combines data, in our case now the width and the height. For the circle, we had just the radius. Now let's take another color. And logic, as you can see here. This logic operates on the data up here, and that's what the class is all about. We have logic, and this logic operates on the properties that we have up here, okay? And that is what classes is all about. Combine data with methods, make them a union, and this is what we call a class, okay? Very nice. So now that we have fixed the rectangle, let's try the triangle. On the left-hand side, you see the circle, or maybe let's do it a little bit differently. So I take the rectangle on the left-hand side, and on the right-hand side, we have the triangle. I ask you now, if you rewatch this video, or if you are not in my class and you're just watching this video, pause the video here and try to recap what we did at circle, what we did at rectangle, and try to apply exactly the same steps for the triangle. That is your task. Pause the video here and try it on your own. Welcome back. I hope you really did the exercise. You really tried to apply what we did for rectangle and circle with the triangle. I would like to show it to you, but this time I will do it a little bit faster, okay? So let's remove the static and change it to triangle, because that is a beautiful name for our class. Now, the constructor is a public method with the same name as the class. Which parameter do we need? Which parameter characterize a triangle? These two guys here, the base length and the height. What did we do in the rectangle side? We created two properties where we can store the attributes that make up the rectangle, and exactly that is what we do in the triangle. So let's create two properties, and now I will show you a trick. You do not need to remember it, but it will make your life easier. So watch what I'm going to do. I'm going to type prop, which is the name for the concept here, property, right? And then I simply press the tab key, and you see it now fills the rest of the line for me. I just have to specify the data type, which is double. Press tab again. That brings me to the name of the property, and I can call it base length because this is what I want to create. Let me show you how fast you can be. Prop, tab, double, tab, height, done. See? With just a few keystrokes, you can easily create these properties, because in real life, you create a lot of these properties every single day as a C# developers. So therefore, remember this shortcut, prop, tab, and then the system, the editor, will lead you through the creation of the property. Now let's go back to the constructor and do exactly the same what we did here, but this time we are going to store base length and height. Uppercase B, base length, equals to base length with a lowercase b. Height with an uppercase H equals height with a lowercase h, because we are transferring the input parameter into our class's storage. Now let's refactor our methods. This one will become a property. Can remember, we called it area, and we simply changed the logic to this one here. Of course, we have to change it so that it uses our properties. Great, now we have the area. And last but not least, let's create the scale method. Let's change it to void. It doesn't return anything, it scales itself. Hey triangle, scale yourself. This is what we are doing here. Scale. We do no longer need the arguments because they are stored here in our properties, and we can change the logic so that the logic changes the content of our class. We have to do it a little bit differently, something like this, and now we are good. Now let me show you all three classes here, side by side. Here we have the triangle, let's put the rectangle here, and here we have the circle. And then we try to recognize a pattern. This will be important in the next lesson. Now check it out. Here we have a class, here we have a class, here we have a class. Then in red we have a constructor which receives the characterizing features, in this case the radius. Here we have the constructor with the width and the height. Here we have a constructor with the base length and the height. You can see the height here, but I'm sure you can remember it. Next, we had properties where we store the content, where we store the attributes of our circle, our rectangle, and our triangle. Here we have the properties. Here we have the properties. And last but not least, we have, let's use pink here, we have the logic. For simple calculations, we used a read-only property, and for something that really manipulates our object, we use the method. So here we have the logic, and here we have the logic. Do you see the pattern? Circle, rectangle, and triangle are really very similar, and this will become an important factor in the upcoming weeks. So just keep that in mind. For now, it helps us to exercise the same concepts over and over again. It should help you getting used to things like classes, constructors, properties, and methods. Very nice. So the last thing that we have to do is we have to change our program, the user interface, if you want to put it that way. So what I'm going to do is I'm going to, let's keep this one just as it is because it's fine. It's asking for width and height and radius and base length and things like that. That is fine. That doesn't change. The things that change are here where we really interact with our classes. Now, here we have to change things fundamentally, because we cannot just call the methods. That was fine with the static classes because, let me repeat that again, static classes are just a container for methods which logically belong to each other, but at the end of the day, they are only loosely coupled. But now we have classes. See, we change the method as follows. We cannot do that anymore. Instead, we are going to create a new, in this case, rectangle. We are going to say var rect equals to, and now we are going to use the new keyword and create the rectangle here. Now we can give it the parameters, width and height. That seems obvious. But how do we get the area now? Can you guess it? Yes, we are going to use this object. If you take a class and you create an instance of this class with new, we call the result a so-called object. You only have a single class. It's like a blueprint, like a template. And if you apply the new operator to it, you take it and you create an instance of it. And these are the objects. Could we have multiple rectangles? Of course, we can call new as often as we want. We can create 2 rectangles, 3 rectangles, 4 rectangles. I really don't care. We can create as many rectangles that we like. Okay, so remember that. I will zoom in and write that down for you. This is what we call the class. With new, we create an instance of a class. And on the left-hand side, we have our object. Rectangle, this lowercase rect is the object, the instance of the class. We have a single class and we have a lot of objects. Let me symbolize that by adding some dots here. We can have multiple objects of a single class. They all can have different widths and heights. That's perfectly fine. Okay, that's an important thing. Now, how can we calculate the area? Well, it's simple. We simply take the object, rect, and call, in this case, the property. We say, hey, rect, you know yourself how to calculate the area. Calculate the area and give me the result. This is exactly what we do here. So we are talking to exactly that rect. And if we have multiple instances of rectangles, then we can ask each and every rectangle about its area. And we can also tell the rectangle to scale itself. The rectangle knows how it scales. For instance, I think this was the factor, right? Oops, sorry. The factor. Did I call it factor? Yes, I called it factor. I simply tell the rectangle to scale itself. This is now a member method. It's a method that belongs to the rectangle, and so the rectangle knows how to execute this. If I have multiple rectangles, I can scale all of them with different factors. Every rectangle has its own width and height. Now, how can we get the new width and height after the scale method? Very simple. We simply say this should be the width, and here we say rect, this should be the height. And how do we get the new area? Much easier than before. A lot of stuff was going on. Here we just say rect.area. And that's it. Isn't this code much cleaner? Create the rectangle. The rectangle knows itself how to scale. The rectangle knows itself what the width and the height is, and of course how to calculate the area. Okay, I'm pretty sure that not everybody got the concept so far. So let's practice that again with the circle. First, we create the circle. Var circle equals to new circle. And pass in the radius as the parameter. See, just like up here. Now we have, can you remember how a circle with the lowercase c was called? We have an object. Yes, on the left-hand side, this was called the object. And on the right-hand side, we have the class. From a single class, we can create multiple objects. And in our case, every circle can have its own radius. Now, how do we calculate the area? Pretty simple. We take the circle and ask for the property radius. Let me show you the circle here on the right-hand side so you can really understand what's going on. Let me move that here. See, here we have the constructor, and here we are calling this constructor. Let's take another color. Here we have the property. And with that, we are simply calling into this property here. And the circle itself knows how to calculate the area. That's the whole point of it. Do you understand how they belong together, how they work together? I hope you do. So let's remove the circle. And now the scaling works exactly like up here. We simply say circle.scale and pass in the factor. Because just like the rectangle, the circle knows how to scale itself. We don't have to teach that to the circle. Well, and the rest is pretty simple. We say, hey circle, give me your radius. Hey circle, here, give me your new area. Circle.area. Note that all the properties here, and all the methods, they operate on the object, not on the class. That's the difference between static classes and regular classes. For regular classes, you always have to add the new keyword in order to create an instance of it. For static classes, you do not need to do that because they are just a loose collection of methods. They don't have data. Well, they can have data, but that is too complicated for now. For now, we simply say they don't have data. Okay, third one. Again, I ask you to pause the video here. Pause the video and try to fix the triangle part on your own. Take the rectangle and the circle as your template. Yeah? This is your guidance. This shows you how to do it. Try it yourself. Fix all the red squigglies down here and continue the video once you did that. Welcome back. I hope you really tried it. I will show you how to do it, and again, I will make it a little bit faster. I will simply say var triangle and use the new keyword to create a new triangle. In this case, I have to pass in the base length and the height because these are the defining factors of a triangle. Now, the area is pretty simple. We simply say triangle.area, use the property to read the area. Scaling is simple because just like the circle and the rectangle, the triangle knows how to scale itself. So I'm going to say triangle.scale, and using the factor here gives you a larger or smaller triangle depending on whether the factor is greater 1 or lower 1. And last but not least, we use that one. We say, hey, give me, dear triangle, give me your base length. And here we say, hey, triangle, give me your height. And last but not least, here we say, hey, triangle, where is it? Triangle, give me your area. And we're done. See? Exactly the same cooking recipe if you want. We create a new object, we access properties, we call methods, we access properties again, and everything is neatly stored inside of our objects here. Isn't that beautiful? Isn't that code much cleaner? We do not have to pass the radius and the width all around. We store it neatly into our classes, and then the classes know how to do their job themselves. We simply have to trigger it, scale yourself, and they know what to do. I hope you understood what I wanted to tell you. And of course, I have an exercise and homework for you. Now we have a rectangle, now we have a circle, and we have a triangle. And I want you at home to add a fourth geometric figure to our exercise. Can you guess what it is? I want you to add an ellipse. Let me show you how we do that. Let me quickly go to my... Oh, I closed it up. I'm very sorry. Give me a second. I open up the specification of the homework. Here is the specification of the homework. Of course, this specification is available on your GitHub repository. What is your homework? Repeat, repeat, repeat. Rewatch this video. If you need, rewatch it 2 times, 3 times. Send me questions via Discord. It's important that you understand these concepts. And then, as I mentioned before, add the ellipse class. Now, an ellipse looks somewhat like this. Let's say this is an ellipse. Here we have 2 determining factors. The first one is the longest radius. It's that one. And the second one, let's use a different color, is this one. That's the shortest radius. I used it in yellow. So with these 2 properties, we can calculate the area of the ellipse by multiplying A, the longest radius, B, the shortest radius, and pi. So pi times A times B is the area of the ellipse. And how does scaling work? Let me quickly take another color and show you what I mean. So if I scale this rectangle, we have a new longest radius, we have a new shortest radius, so we have an A dash and B dash here, and the calculation logic works exactly the same as for the triangles, for the rectangles, and for rectangles. You simply take the square root of the factor of the enlarging factor, or the enlarging factor, and multiply it with the old value. So it's exactly the same pattern as we have seen before, and this is exactly your job. So take the code that you learned here, that you created here together with me during this video, copy either the circle or the rectangle or the triangle, and change the logic so that it represents an ellipse. And then you take the app, the user interface, you let the user choose an additional geometric figure, ellipse, ask the user for the necessary properties, longest radius and shortest radius, and add another code block here where you simply add the ellipse part. Okay, so where you create a new ellipse, where you calculate the old area, scale it by a factor, and calculate the new area. Okay, this was an exciting step into the world of object-oriented programming. I hope you understood everything. I hope it is clear. If not, send me questions, ask me questions during the lessons. I'm looking forward to your questions. Have a very nice day, and I'm looking forward to seeing your solutions. Bye.